Okay, here is a scenario. You have a 50-page legal contract document, and someone asked a very specific question about the payment term. Your system returned 3 unrelated paragraphs about liability clauses. So the system is failed. Not because of the embedding model, not because of the vector database, not because of large language model too. It is because of how the document cut up before anything happened, called chunking. This is the one step almost nobody talking about it is responsible for RAG failure. Today, we're going to see every RAG chunking strategies, what it does, and when to use it. In case if you don't know me, I am Salam Lak. I build different RAG systems for real estate and finance businesses, and this is a video all about chunking strategies. Let's get into it. Quick remember, in a RAG system, before your document gets embedded and stored, they get split into smaller pieces called chunks. Each chunk gets its own vector, and when someone asks a question, the system finds the chunk whose vectors are closest to the question vector. Here is the problem. If your chunk are cut badly, maybe a key sentence is split across 2 chunks, or the chunk mixes 2 completely different topics, the embedding of the chunk becomes confused, and confused embedding leads to wrong retrieval. Wrong retrieval leads to wrong answer. You could have the best language model in the world. If the chunk is going in are bad, the answer coming out will be bad. That is simple. So there is 8 strategies of chunking. So let's get into it one by one. Fixed size chunking. It is the simplest one. You decide a number size 512 is token, and you cut the document every 512 token. Doesn't matter if you are in mid sentence or doesn't matter if you are in mid paragraph. Just cut. It is fast and it is predictable. It is easy to set up. But the obvious problem is it has zero awareness of your content. A sentence that starts in chunk 3 might finish in chunk 4. An idea that spans 2 paragraphs gets split in half. The model tries to understand a fragment with no beginning or end. Use this when your documents are very uniform, like a database record or structured logs, and you just need a quick baseline to start testing. But honestly, it is a starting point. It is not a destination. Strategy 2 is sliding window chunking. This is a fixed size chunking with one important upgrade: overlap. Instead of clean cuts with no connection between chunks, you repeat a portion of text at the boundary. So the end of chunk 1 also appears at the start of chunk 2, typically around 10 to 20% of the chunk size. So for 512 token chunk, you would overlap about 128 tokens. That is actually the industry standard starting configuration, and it is a default in LangChain, like for recursive character text splitter. The overlap means nothing completely lost at the boundary. An idea that started 2 chunks still appear fully in at least one of them. The downside for this strategy is more chunks, more storage, higher embedding costs, and finding the right overlap percentage takes some tuning. But for dense technical documents, this is plain fixed almost every time. Sentence and paragraph chunking. So now we are getting into a method that actually read your document structure. Sentence chunking uses natural language processing tool to detect where the sentence ends, full stop, new lines, and group a fixed numbers of complete sentence per chunk. No sentence ever gets split across two chunks. Each chunk starts clean and end clean. This is great for question and answer systems where the answer to the question typically live in one or two sentences. For news articles, for product description, for FAQ documents, sentence chunking works very well. And the paragraph chunking goes one level up. One paragraph equals one chunk. The system splits at blank lines or paragraph markers, respecting exactly how the author organized their thought. This is the ideal for research papers, legal contracts, blog posts. So the document where each paragraph covers a distinct idea. The chunks are semantically clean because the author already did the organized work for you. The catch with both, if your source documents are poorly formatted with inconsistent spacing or missing punctuation, this method is very challenging, or it will struggle. They rely on the document being well structured to work well. So either sentence or paragraph chunking is rely on a document that's being well structured to work well. Otherwise, it is not ideal. Strategy 4 is recursive character text splitting. This is the one that worth knowing by name because it is production standard. It is what is almost every team reaches for when they don't know where else to use. Here is how it works. It tries priority list of separators in order. First, it tries to split at double new lines or paragraphs. If that product produces a chunk that are still too large, it falls back to the single new line. Still too large, it tries sentence boundaries, then clause boundaries, then word boundaries, then individual character as a list result. It keeps trying to until the chunks are within your target size. The result, it always respects with the most natural boundaries it can find. It never cuts a mid-sentence if it can avoid it, and it handles messy, inconsistent formatted documents, generally PDF, HTML, Markdown files, mixed content, all of it. Zero contract compute costs compared to fixed size, and almost always produce better chunks. This is your default for production system handling a mixed document type. Strategy 5 is semantic chunking. Now here is where things get genuinely interesting. Almost all the methods so far we uses rules, cut here, split here. Semantic chunks use meaning to decide where to split. I mean, other chunking strategy was, as we saw, that is they use rules, but in semantic chunk uses meaning. And here is how it works. The system embedded every sentence individually. Then it measures the cosine similarity between each pair of adjustment sentences. When that similarity scores drop sharply, meaning the topic has changed, it inserts a chunk boundary right here. So the chunk are not a fixed set, they are as long as the topic lasts. When the document moves to new idea, the new chunks start. The result, every chunk covers exactly one topic, maximally coherent, no mixed topic chunks confusing the embeddings. and the numbers back this up. Semantic chunking consistently improve read-survival hit rate by 10 to 25% compared to fixed site splitting. The trade-off, it is slower at index time because it has to embed every sentence during chunking, not just during storage. And the similarity threshold needs turning. But when read-survival precision is your priority, you have the compute budget. This is the better choice. Strategy 6, it is document structure and contextual chunking. Two more strategies and are the most powerful. Document structure chunking reads the actual formatting of your document, like heading, subheading, number section, table rows, list of items, and uses this as a natural chunk boundaries. Each chunk maps to a complex section as the author intended. And here is a bonus. Every chunk automatically carries rich metadata, section title, heading label, page number, all available from the document structure. This lets you filter read-survival very precisely and only search section 3 or only looks at document dated after 2023. Best for legal contract like API documentation and PDF with a clear heading or anything where the structure of the document is meaningful. Now let's see contextual chunking. This is the most advanced method and honestly the most impressive one. After you split the document into chunks, using any method, you can run each chunk through an LLM or large language model. The large language model reads the chunk alongside its surrounding document context and writes a 1 or 2 sentence summary that situates this chunk within the border document. Something like, this section discusses the payment term for enterprise contract, and that summary gets prepended to the chunk before embedding. So now every vector isn't just representing the chunk in isolation. It represents the chunk with its context. A paragraph that would otherwise seem disconnected how clearly belongs to its document. The result, read-survival failure rate dropped by 49% compared to standard chunking. That is mass improvement really. And the cost on one LLM or large language models per chunk at index time. For large document collections that add up very fast, use the enterprise RAG where an answer quickly justify the investment, legal complaints, healthcare, and financial documents. This is very important. For those things, we need to use context chunking. So 8 strategies. And how do you actually decide? Here is a honest practical path. Start with recursive splitting like 512 tokens per 128 overlap. It is your baseline and 0 extra cost. Handle mixed documents. It is better for plain fixed size. Measure your read-survival hit rate. How often are the right chunk coming back? If it is below 70%, move to semantic chunking. If your document have a clear heading, like legal contract, financial report, API costs, documents, use a document structure chunking. You will get a better chunks and free metadata filtering also. If you need maximum performance and the cost is justified, contextual chunking is the only option, and it is very expensive at index time, but accuracy gain is the real. And remember, there is no universal based strategy. The right choice depends on your document type, your query type, your latency budgets, and how much accuracy matters for your specific use cases. So chunking is where the most RAG systems win or lose. Now you know every tool available. So this was a video about chunking strategies. If you get this video is useful, please hit the like button and make sure that you subscribe so you will not miss the next video.